Hello and welcome to the Embodied Carbon module of the Sustainable Building Training series. In this short video, you can expect to learn about what embodied carbon is, why it is important, and how we can reduce it in buildings. Embodied carbon considers all greenhouse gas emissions that are emitted in the full life cycle of the building, from extraction of raw materials through transportation, manufacturing, construction, maintaining and replacement, potential demolition, and its future life. As you might guess, every construction material has an embodied carbon figure or value attached to it, even before it is used in buildings. This is called upfront carbon or cradle-to-gate embodied carbon and includes all carbon dioxide emissions during the manufacturing processes of a certain construction material before the material is transported to the construction site. Upfront carbon varies from material to material. A timber beam, for example, has lower embodied carbon than a concrete beam, carrying the same structural loads. This is mainly because the production of timber is less energy and carbon intensive. Similarly, a building made with timber superstructure would have a very different embodied carbon than a building made with a steel structure. In discussions about embodied carbon, you also might hear about operational carbon. Operational carbon is different than embodied carbon, as operational carbon is about all carbon dioxide emissions from the energy and electricity we consume to keep our buildings warm, cool, illuminated, and powered. Operational carbon can be reduced by strategies such as making buildings super-insulated and airtight. The question is now why we should care about embodied carbon.
The first reason is that the upfront carbon of materials used in construction, such as concrete and metals, is responsible for 11% of greenhouse gas emissions globally, according to the United Nations Environment Program data. Building envelope and interior materials are estimated to be responsible for roughly another 6 to 8%. The second reason is that the share of embodied carbon in buildings' carbon footprint is going to increase as buildings are going to become more and more energy efficient in future decades. For example, in a net zero energy building, between 75 and 100% of the life cycle carbon emissions will be caused by embodied carbon. A third reason is that according to a UN Environment Global Status report, embodied carbon is going to be responsible for about 50% of the carbon emissions of new construction built between now and 2050. Therefore, there is an urgency to limit embodied carbon of construction activities if we are to limit climate change and global warming.
It is because of this urgency that the United States government acknowledges the significance of embodied carbon in achieving net zero emission status, and the Federal Sustainability Plan calls for embodied carbon reduction in federal supply chain. Additionally, green building rating systems such as Leadership in Energy and Environmental Design LEED or Living Building Challenge LBC consider embodied carbon in their certification systems. The best way to limit embodied carbon is to pursue the circular economy and the reduce, reuse, sequester strategy. Adaptive reuse of an existing project, for example, could lead to significant reduction of construction material consumption and therefore embodied carbon. It is also important to reduce the consumption of new materials as much as possible and replace high embodied carbon materials with low embodied carbon alternatives. Finally, using materials with carbon sequestration capability, such as responsibly managed timber, could balance some of the embodied carbon emissions and lead to lesser overall embodied carbon. In embodied carbon discussions, it is also important to be aware of embodied carbon assessment tools. Lifecycle analysis tools such as the Athena Impact Estimator for buildings, Tally, or one-click LCA are all great tools to estimate embodied carbon for a project. The Embodied Carbon in Construction Calculator, EC3, is another great tool once projects reach the material specification and procurement phase. This tool is based on a database of product-specific, third-party verified environmental product declaration (EPDs) that could be used for embodied carbon assessment. Thank you for watching this short video about embodied carbon in buildings, and I hope you found the information useful. Suggested readings about embodied carbon can be found at the end of this video. Also, please watch the other videos in this series to better understand how sustainable buildings can help reduce negative impacts on the environment while creating healthier spaces for people to live and work in.